Alright guys, today we're going to compare some PCB vendors. So I was checking these three vendors, Next PCB, PCB Way, and GLC PCB. And I found this to be the best as per my requirement. So I'm trying to get a 6-layer board with impedance control 50 ohm wherever the signal is routed, and the dimension I'm going to measure right now, I believe it's roughly 360 by 90, and we're going to measure that and for 5 quantity, and it has a good web interface and data for the impedance as well. So yeah, and it can produce stencil, it can produce assembly, it can assemble the board for you. um, Yeah, so I'm gonna go measure. Let's measure the dimension of the board first. I don't remember exactly what was the dimension. So snap two segment. Okay, cool. Snap two segment. All right, and put right here. Done. So it's 382. Okay, let's see what's the unit that I'm setting right now. Parameters. So there's okay, primary dimension, which is on the top, is in millimeter and bottom is in inch. Okay, so the decimal 2 unit, 3 place decimal. All right, 382 by 90. Cool. So let us go right here. X is 90, Y is 382. Cool. Okay, we just need 5 board. So let's go 6-layer instant code. Okay, so we're going to choose the. So we've chosen the layer 6. Cool, dimension done, quantity done, industrial, consumer electronics fine, single PCB design, different designs 1, and thickness 1.6 is the default. Okay, if I change to 2, what's the change in price? Yeah, it's a lot. Huge difference in the price. Okay, 1.2, not much difference. Not change at all. Okay, so 1.2 or 1.6. I think 1.6 is standard, so we're gonna go for 1.6. And the PCB solder mask, color, it's gonna be, it's okay to be green. Let's see what's the difference in the cost if it changes. Yeah, quite a lot. So black, 84 purple, 84 red, 84. So okay, any change other than green, it's gonna be like, yeah. Silk screen, white color is good enough, and this is the material type for FR4. I'm gonna go for this. This is mainly the TG. I believe is it's a parameter for heat related thing. Um, yeah, so the lower it is, the less heat tolerance. The higher it is, more heat tolerance. I think I have a document open related to this. Okay, here. Yeah, normally high TC refers to high heat resistance, right? Um, uh, okay. Um, if the TC is the heat resistance, so yeah, so if the TC um, chemical resistance, stability of condition will be improved as well, right? So the one that I'm going to design, it's doesn't need all these things, right? So yeah, I have some other board which might need this. Anyway, so therefore the difference between use a hot state, especially that I'm not sure um, from better than FR4. Okay, spec of mechanical strength. Yeah, so definitely like if I choose this, there should be increase in price by it, but not much. So I think I can choose this. Yeah. All right. So surface finish, definitely I'm gonna go for this. Um, yep. And so this is okay with lead free, and then gold plated. This surface finish. I think I have. Yep. So so HSL stands for hot air soldering level. The cons process is cheaper, definitely, as you saw earlier, but the thickness will be, it can be lead or lead free, as we see over here. Yeah, with lead and lead free. And then what else? Yeah, INIC stands for electroless nickel immersion gold. Um, So advantage easy to apply of its hassle is advantage of hassle is easy to apply, easily available, blah blah blah. Disadvantage thicker than others. Okay, high temperature streak. All right, so availability, durability, solubility, lead free. Cost, definitely. Negative sensitive surface, it prone to high temperature. If not handled carefully, it can lead to gold wire burning issue, which makes quality check. Okay. Yeah, I see this, but we are not doing any integrated circuit design or any gold wire bonding. So, yeah, um, it's extremely thin if not handled properly. Yeah, yeah, reworking it's gonna be like since it's very thin, the solar the copper might get detached easily. Yeah, uproot. Okay, so anyway, we are going to choose um, INIC and to you fine. And copper, outer copper weight is one oos and inner point. Okay, let's if I change to two, let's oh, okay. And for high voltage, sorry, yeah, high power, high voltage design, I can choose this, but now it's not necessary. Inner, okay, not much change. Yeah, anyway, so I'm gonna put zero point 0.5. So what's the translation between this and the thickness of the copper, right? So the thing is like, let me just turn on the 3D view. Let's let's have a look at the 3D view. Okay, let's close this. Okay, all right. So um, okay, let me remove the silk screen top, paste more stuff, and this is the top. Let me remove other. Yeah, so we have these planes, right, separated by the dielectric as per the stack up. Like for example, this is top plane. I'm talking about the thickness of this particular plane, and this would be the dielectric. Sorry for the noise. Then we have layer two. Then again the dielectric, layer three. So basically, I'm talking about um, this. Let me remove this dielectric. This layer right here. So one is for external for top and the bottom right here, and these are the internal layer. Yeah, so this is one ooze and is zero point 0.5. So let's see what's the translation in millimeter, right? Um, I already have the web page open. Yeah. So as you can see here, 1 oz corresponds to 0.0348, right? Yeah, so that's the thickness that we are looking at, right? So as per that, we'll change the stack up later on once we, specify. So a few things that we need to update. So the thickness um, of the dielectric, once we specify the, you know, once we have the stack up ready as per the impedance control, and then what else? And then yeah, of course, the constraints of the design has to be updated as well because the as per the impedance control and the thickness of the dielectric and the thickness of the copper and thickness of the board, the signal layers need to have a particular width that we need to maintain. Yeah, that can be updated right here in the physical, all layers, and then yeah, line width, minimum, maximum, we can update right here so that we can start routing as well. Um, yeah, so let me turn this off. Okay, all on, fine. Yeah, so all right. Okay, so 0.0348 and for 0.5 was for 0.5 was about 0.03 for thickness about 6 mm, point for the center 90. What is it? Okay, anyway, we're going to see this when we go to the stack up, right? So for now, this is the information that we have from this table. Yeah. So from if I change from 1 to 2, is it linear? Like, is it just 2 times? 2, 6, 4, 8. No, it's not exactly linear. It's somewhere near, but it's not exactly right. We just multiply this by 2. Okay, let's say 8 to 16, 1. Now 4, 8, 9. Oh no, it is. Okay. Also, it should be half. Zero point 0.5 oz divided. It should be 0.03 divided by 2, right? So that is 0.01 something something. Yeah. So anyway, so impedance control. Let's come to the impedance control later on. Epoxy filled cap we are covering. Okay. Let's see what if I change this. What's the impact on the price? I don't see any impact on the price. Oh, what is this? Change suddenly. Copper paste filled and capped. Anyway, vias should be at most 0.5 millimeter diameter to avoid incomplete filling. Vias quality designs will be left unfilled. Vias are filled with epoxy resin. Okay, got it. Okay, so let's choose the default and then minimum hole size diameter. Okay, I'm going to choose zero point 0.3 as it is. Yeah, as you can see, yeah, okay, huge jump in the price. Yeah, at least for the prototype, we don't want to change. We don't want to have a high cost. Okay, so zero point 0.3 millimeter is the via. So let's check what's the via that I'm using. right now. Turn off. Let me just turn layer 1. In fact, let's turn all. So the minimum finish size that I have is this drill chart, 0.38, right? Okay, I think which is good. Is it this? I believe this is the VM. Okay, anyway, let's check that. What I'm gonna do is I'm gonna quickly route on the top layer and place this VR right here. Done. Okay, and then I'm gonna save this. Yes, manufacturing. Um, NC Trill Legend. Okay, yeah. So previously it was 7, it should become 8. Yeah, as you can see, it's become 8 because we have added one VR right here. Yeah, so we're confirmed like 0.3 is the finish size, drill size, 0.38. So we're good, right? As per constraints that, as per the parameters that we're choosing from TLC PCB. And then what else? Mark on PCB order number is good enough. Yep. Okay. Then yeah, stencil. Okay, we can add a stencil. Okay. Yeah. Cool. Not a big deal. Um. So from stencil, we're gonna need what information? Solder paste information, right? Okay. Yeah. So we're just gonna need. Let me turn off everything. And I believe it's in pin solder paste top. Yeah. So yeah. So stencil. It's gonna look like stencil PCB images. Yeah, it's gonna look something like this. It is too bad. Yeah, it's gonna look something like this, and this cutout will be coming from this data right here, paste mask top, right, and even the paste mask bottom as well. So two stencil we're gonna receive, one for the top and one for the bottom, right? Um, yeah. So let's close this and then okay. So we have $87 right now. Uh, 5 to 6 days delivery. Finally, the most one of the most important thing is the impedance control. Yes, then there are already default. Stack up that is already available. Let's quickly check. So this is not exactly 0.6 millimeter that we chose. Anyway, let's check the price difference. We're gonna come in details of this nomenclature. What if I choose this? Okay, it's changed. If I choose this, changed. Okay, so this is the only one that is not changed, right? Yeah, so and we can view the stack up of this particular information right here. Yeah. Uh, so what was the thickness? 1.53. Okay, let's copy this. Plus minus 10 tolerance. Okay, so I'm going to go to impedance calculator. Um, we need 6. Is it possible to enter the exact number? No. So this is the closest PCB thickness that we have in our 0.5 ohms, 1 ohms. We want in millimeter. Um, Um, okay, let's layers single and then bottom reference layer 5. Okay, um, top reference, bottom reference. Um, Signal layer 5. Hmm. Layer 6. Okay, and calculate. Yeah, so we have the trace width right here. So layer 1 is signal and layer 2 is say ground. Um, that's the reference that I'm talking about. So in our stack up, it's gonna be something like that. So top and then ground. Um, yeah, bottom, and this can be ground or signal. Um, yeah. Um, okay. So anyway, so 0.15 is the thickness, and we wanted to choose this, right? 3313. So okay, let's see the nomenclature first. GLC company name, of course, GLC PCB. 06 stands for 6 layer, and 16 stands for 1.6 thickness. I don't know what is 1/8. 331 3 is the pre-rack. So whenever we look into any stack up, there will be a core and a pre-rack. The difference is like this is prop FR4 and this will be thinner glass, but yeah, thinner than this is, I think. Yeah. So if you see, it's 0.5 and 0.0094. Yeah, so all this thickness, this data will be, I think we're going to need to enter over here once we decide the stack up. We're going to do that as well. But for now, let's decide the stack up first. Okay, so yeah, so we wanted to choose this, right? 313, 313. I have that GL PCB. Yeah, so as you can see, count board thickness, exterior copper, interior copper, prereq type, right? Um, and okay, this is a user guide for impedance calculator. Layers, all the units, impedance, layer, impedance, reference layer above. So internal layer does not need to be layer below the settings for. Okay, yeah, of course. Um, yeah, so you can go through. I'm gonna put this link on the description as well. Yeah, yeah. I think they've defined the thickness as well. 1.6 mil for one hose. Internal thickness. So the internal thickness, when you say one hose, it has a different, um, different thickness. 1.2 for internal, 1.6 for external for the same one hose. Um, yeah, prereq type, core thickness, and we have the dielectric constant. Okay, so all the information are here. This is what I like about GLC PCB. Okay, so coming back to the point, we are choosing this 313, right? control. F313. What is that? 3313. Yeah, so this is the one that we are choosing, right? Core point one. Um, yeah. Um, okay, so yes. And view stack up. I'm gonna choose 3313 here as well. Just 0183313. So don't confuse with 3313A and 3313 because they are different, as you can see here. This will be much costlier. Yeah, so let me choose this. So this is the final data that we have. Let's compare quickly with this. So copper thickness 0.35, gold 0.35, pre-rack 0.09, inner layer 0.01, core 0.5. In the pre-rack, their same. The pre-rack internal layer is 0.108. Okay. Then what else? Everything should be same. Yeah. Okay. Yeah, it is. So yeah, we are good. And now finally, let's confirm. Yes. So at the end of the day, this is what we have. 87, 2 to 4 business, no, 5 days, 5 business day, um, and the stencil. Okay, work together with PCB. So this is with including stencil, right? Um, yeah. So let's quickly enter this information in the stack up. Um, Let me close this. Where is the stack up? Okay. Um, okay. Dielectric. Let me put this side by side so that I can copy easily. Not this one. Okay. No, let's. Okay. So where is that? Um, okay, here it is. Stack up. Mm, okay. Pre-rack. B. Let's paste this. Copy. Let's paste this. Copy. Let's paste this. Copy. Inner layer. Core. here, pre-rack. Right, so we are done. We are good, I guess. What else do we need to change? Mm, okay, I think that's it. Apply. Okay, then let's check the 3D view once again. Yeah, and let's jump it right here. And yeah, we can see the difference, right? So this is the topmost layer. Oh, this is the topmost layer, and this is the internal layer, and this is the bottom layer. You can see the difference in the thickness, as you can see. Um, yeah. And what about the dielectric? Let's enable them one by one. Um, yeah, let me place this way, and this dielectric is much thicker, as you can see. Yep. We have copper plane. I didn't see any copper plane. Okay, I think I haven't put any copper plane yet in the design, so that's the reason why. So we have layer 4 here. I don't have copper plane yet. Then the electric, and layer 5, then layer 6. So this is stack up, right? So 1, 2, 3, 4, 5, and 6. Yep. So this is the final stack up that we are choosing. The thickness, is it correct? Let's check once again. 0.5384, right? Point 0.5384. Okay, cool. Yeah, so we are good. Yeah, thickness match, connector plane, blah blah blah. Apply. Okay, yeah, good. I think that's all for this video. Ciao, guys.